Okay, so I've written down the two equations that we would be likely to use, and because we are rotating or revolving the arc about the x-axis, let's go ahead and focus on the second equation here. Okay, and now in order to get started, we really need to parameterize this curve. So we're told that the arc is the top of a is the so our parametric curve is part of a circle, and the circle is x squared plus y squared equals 9. So we know that that is going to be a circle of radius 3 centered at the origin. And we're told that we want the part of the circle that starts at 3 comma 0 and stops at 3 over 2 comma 3 root 3 over 2. And now we just so we just so happen that it just so happens that we have, it'll go to about right here. So let's see here. So now this is going to be, so this is going to be 3 comma 0, and up top this is going to be 3 halves comma 3 root 3 over 2. Okay. Now to parameterize a circle, one thing we can do is we can just look here and see that, let's see here. We can look here and see that this is the same thing as x squared plus y squared equals 3 squared. Okay. And if we let x equal, let's see here, cosine squared t, x squared is going to be cosine squared t, y squared is going to be sine squared t, that would just give us 1, right? So to get the unit circle, we used cosine squared t plus sine squared t equals 1. So if we want to get this circle that's centered at the origin and has a radius of 3, let's multiply this equation by 9. So now we would get 9 cosine squared t plus 9 sine squared t equals 9. And now it's easy to see that this is the same thing as 3 cosine t squared plus 3 sine t squared equals 9. So we should, in order to parameterize this, let x equal, so we'll let x equal 3 cosine t, and we'll let y equal 3 sine t. Okay, so now, let's say we've got our formula, and we know that we want to let x equal 3 cosine t, and y is going to equal 3 sine t, and t is going to start at 0. And how do we figure out where t stops? Well, we need to know for what value of t is 3 halves equal to 3 cosine t. Right, we've got to solve for t. So that means 1 half is going to be cosine t. And what is t going to be? Turns out t is going to be pi over 3. So make sure you have your unit circle. That's how we'll know that t is going to be in between 0 and pi over 3. So now this is helpful because we are ready to just plug these values into our equation for the area of our surface of revolution. Okay, so SA is equal to 2 pi. A is going to be 0, B is going to be pi over 3. Our f of t is the is the x-coordinate, so we'll have 3 cosine t times the square root. Now what is dx dt? If our x is 3 cosine t, then dx dt is going to be negative 3 sine t. Okay, and if our y is equal to 3 sine t, then dy dt is equal to 3 cosine t. Okay, so what do we have here? So we need negative 3 sine t squared plus 3 cosine t squared, and all of that dt. I'm starting to smile because on the inside here I'm going to have 9 sine squared t plus 9 cosine squared t. I need the square root of that, 3 cosine t. I can bring that 9 out, so I'll have 3 times the square root of sine squared t plus cosine squared t. That makes sense, right? So that's going to be 1, so we'll just have 3 dt integral 0 to pi over 3, 2 pi. In fact, 3 cosine t, 0 to 2 pi, 0 to pi over 3, 2 pi, dt. And so now this 3 and this 3 can come outside. We can factor those terms out because they're just constants. So that'll be 18 pi times the integral from 0 to pi over 3 of cosine t. Because remember, this sine squared t plus cosine squared t is the same thing as 1. That's our Pythagorean identity, dt. Now, what is the integral of cosine t? An antiderivative will be sine t. So we need sine t evaluated at 0 and pi over 3. Okay, so we'll have 18 pi times, now what is sine of pi over 3? That's going to be 1/2. What is sine of 0? That is going to be, sine of 0 is going to be 0. So let's see here. Let me just verify that I wrote my formula correctly. So revolution about the x-axis, I need f of t. Oh, I got them mixed up. So about the x-axis, I need g of t. Something felt a little weird about this. So about the x-axis, I need g of t. And about the y-axis, I need f of t. And my requirements also need to be modified. So f of t needs to be positive, g of t needs to be greater than or equal to 0. Okay, so now here, my cosine t, sorry about that, y'all. Instead of cosine t, because I'm doing g of t is 3 sine t. Okay? And so now this cosine is going to be sine, sine. Cosine is going to be sine of t. Now the integral of an antiderivative for sine of t is negative cosine t. Okay. And now what is cosine pi over 3? That'll be 1/2. So that is what I should have, so 1/2. And then cosine of 0 is 1. Okay, so we'll have, what is that, negative 1/2 times 18 should be negative 9. Then I've got a negative and a pi, so should get 9 pi. So this is my surface area. Okay. And so it's you can picture what this looks like if you rotate it. You should get kind of like a, I guess kind of like a satellite dish, kind of, right? Okay.